Hello, yeah, I'm sorry my camera got disconnected. Yeah, we were talking about air content. Air content is basically volume of air to the ratio of volume of voids. And previously we looked at percentage air voids. That was volume of air by the total volume of soil. We'll be using these terms in formulas, and these are very easy terms, nothing to worry about. Now we're going to come at bulk unit weight. This is actually the term which always defines the soil, represented by gamma T. It is same as density, where we do mass by volume, weight by volume, so it is weight density here. What will be it? Gamma T is my unit weight density. Total weight by total volume, total weight by total volume. So obviously what is the weight for me? Weight will be Ws, weight of solids, by weight of water. Weight of air actually is equal to 0, sort of 0 approximately. And we have volume, total volume, volume of solids plus volume of water plus volume of air. Air will have a volume. And till now we were looking for the ratios. Now we have a unit weight, so it will have a unit. Unit will be kilonewton per meter cube. You can have it Newton per meter cube. You can also have it kgf per centimeter cube, meter cube, whatever. It depends on whatever weight is given, whatever volume is given to us. Now we have few things are left before we start with the formula part. One thing we should know about is like unit weight. This is a bulk unit weight, means unit weight of soil. Now we have unit weight of solids, unit weight of solids. Now we have unit weights of weight of solids. This is represented by gamma S. Normally what is density? Is the weight by volume, weight of solid, therefore volume of solid. Now actually what I'm talking about is this is soil particle. This is soil particle. It has a lot of soil. So I'm just talking about this one solid particle. This is solid, this is solid. So I'm talking about weight of this solid by volume of this solid, weight of solid by volume of solid. So this is also called absolute unit weight. This is also called absolute because absolute means pure. Like we are taking purely the unit weight of the solid particle, because soil basically comprises of the solid particles. Absolute unit weight, pure, perfect, you can use it. So this is actually the unit weight or absolute unit weight of the solids. Now we're going to start with just last few more term definitions, then we'll begin with the formula part. We have unit weight of water, we have unit weight of water. Unit weight of water is like again gamma W. Earlier we have already seen gamma T, that is bulk unit weight. We have seen gamma S, that is solid unit weight. Now it is gamma W, unit weight of water. We should know this: the water has a maximum density at 4 degrees Celsius, and which is equal to gamma W. We all know this, 9.81 kilonewton per meter cube at the rate 4 degrees Celsius. This question is a suitable question for GATE actually, because many people ignore this thing. Water changes its density with temperature. If you're going to take a density of steam, density of water 50 degrees Celsius, density will change. So whatever calculation we are making in soil engineering, we are considering the density of water to be the highest, that is at 4 degrees Celsius. Simple, it is weight of water by volume of water. Then we come on to the next term, dry unit weight. Again unit weight it is, so gamma, then it is dry, we make it dry, or I use it gamma D. We can use it gamma D. Gamma D, this is a measure of denseness of soil, actually how dense my soil is. And we're going to see the formula. Ratio is numerical form is weight of solids by total volume what this dense now, how it shows dense. This is a total volume. This is the total volume. Now suppose if I have solids still here, this is my weight of solids. It means my I have this much of solid particles in this entire volume, so my soil has certain degree of denseness. But if I increase the WS, if I increase in this numerator part, what is going to happen? This voids will escape. My solid particles will cover this much of part. It will become much more dense. If I'm going to again escape the voids, I can make the void 0. But if I'm also again reducing the voids by compaction or by escaping the water or air from it, so my WS is increasing. It shows my soil is moving towards the denseness. It's going to be more dense. So technically, when we're talking about dry unit weight, so dry unit weight doesn't involve water in the numerical part. It is just the weight of solids by volume of solids. How much solids are there in the particular volume, so that we can find the dryness. We are not actually accounting the weight of water. Okay, then we have saturated unit weight. Saturated unit weight, again unit weight, this is, and saturated can be a suffix. Now what is saturated actually? Saturated again means saturation means all the voids are filled with water. We have seen that earlier in degree of saturation also. Saturation means all the voids are filled with water. Now this weight will be gamma sat, again weight of solids, now weight of water, and we don't have any weight of air, and this weight of water is occupying actually all the voids. Now we have volume of soil, which has volume of solids, volume of water, volume of we don't have air actually, so it becomes volume of solids and volume of water. The picture is like this. Suppose we have weight of solids, volume of solids, and this thing is the water, weight of water, volume of water. There is no room for air. We don't have any air because all the voids are occupied by the water. Now comes the some sort of similar to saturated one. It is called submerged unit weight. When anything is submerged, a term called buoyancy, buoyant force comes in action. If we want to submerge anything in the water, it is because a buoyant force acts on the soil. Now, like if we want to submerge anything in water, water acts an opposite reaction on that particle. So technically here, water will put a buoyant force on soil in the upward direction, and weight of soil will be reduced. We'll represent it by gamma submerged. What is happening here actually is, this is like we had saturated unit weight, which was gamma sat, weight of solids plus water by total volume of soil. So here actually gamma submerged should be same as saturated, because entire soil is saturated. When it is submerged, it should be same, but technically what is happening is this weight is reduced. This weight of actual soil, this it was WS plus WW. This is actually reduced due to the buoyant force of water. And how much reduced by? It is reduced by gamma W. Obviously water will impart this much force only, or whatever liquid is there. In soil we are using only water, so water will reduce the weight of gamma sat by gamma W and will give us gamma sub. Now we come to the sort of a last part of the important definition, but these are the important one. We have something called specific gravity. Specific gravity denoted by G. Now if I say specific gravity of, say, suppose any substance, what is actually? It is actually density or unit weight density or mass density of that substance by same density or mass density of water. That gives us specific gravity of that substance. So here if I talk about specific gravity of solids, not soil, I am talking about solids. If I am just talking about solids, what is going to happen? Weight density of solids by weight density of water. If I'm going to talk about specific gravity of soil, what will happen is weight density of soil by weight density of water. Now these two terms are very important. The importance lies here. What we consider a assumption, you can say, or whatever, like we have a solid particle. Throughout our engineering this subject, the size of this particle won't change, that is volume of solid won't change. Okay, weight ws of solid won't change, and what is gamma s? Gamma of solid is equal to weight of solid particle. This is density, actually unit density again. So weight by volume, density is weight by volume, weight of solid by volume of solid. So this won't change, this won't change. That means gamma solid won't change. If gamma solid is not changing, gamma water won't change, because we are considering at 4 degrees Celsius throughout the engineering subject, and therefore this G of solid won't change. So once we know G of solid, the specific gravity of solids, it will be a very helpful information to solve a question actually. And when we talk about specific gravity of soil, we actually don't use this thing, because here the issue is this gamma of soil keeps on changing, because this gamma of soil also includes weight of water, volume of water, volume of air. So on changing the soil composition, like density, if on changing the voids of the soil, this gamma soil will change, and corresponding this gamma g's of soil will change, specific gravity of soil will change. So we rarely include this in solving our questions, but G of solids, specific gravity of solids, is the best way to solve the questions. We will see how. Before this thing, I'm just left with the last term, and that is an important term. That is relative density, represented by dr. Normally this is used in sand and gravel soil. Relative density is nothing but, like, I have this, again in jar we have all the solids particles. So what is the density of this? That is density. When I'm talking about the relative density is just on a scale of 100 actually. A scale of 100, where 0 is very loose soil, means we have void ratio. What is void ratio? E is the void ratio. If soil is loose, we're going to have lot many voids. That is, E is maximum. This is 0 on 100. If you talk about 100 on a scale, we are very dense. That is, E is minimum, void ratio is minimum. Now how this is happening? This is a laboratory test actually. We have a simple formula. dr, relative density, is equal to E max, maximum void ratio that is possible in that soil, minus E, that what is the actual density at that time. Then again E max minus E minimum. This density comes, actually we take a soil sample. We will take a soil sample. We will move on to the lab, compact it, we'll get E minimum void ratio, and we will keep the soil loose, we'll get E maximum. The maximum, this both are conducted in the laboratory test. We get E minimum, we get E maximum. Once we get this, we will find what is the value of E at the site, at the naturally available soil. And once we find the E, we will find the relative density of that soil at that site. We should learn a table. This is important. Relative density and classification, and easy to learn. It's like we have on a scale of 100, so 0 to 15, then we have 15 to 35, then we have 35 to 65, 65 to 85, then we have 85 to 100. We have very loose here, we have very dense here, And easy way to learn this thing is 0 to 15, and same way 100 to 15, it is going 15 back. So 15 15 is very loose, very dense. Then we talk about plus 20, and here also minus 20, it becomes loose, it becomes dense. And just whatever less in between is medium loose, medium dense, sorry. So 15 15, then 20 20, and whatever rest is medium dense. So as whenever we find the this E ratio here, over here, we can directly put the value, we can find what is the relative density on a scale of 100. If we get it around 50, we can say that soil is medium dense. Fine. Now comes the most important part, and you will see till now what have we learned is, we have learned about water content. Water content was weight of water by weight of solids. Then we started with void ratio. Void ratio is volume of voids by volume of solids. Then we learned porosity, then we learned degree of saturation, then we had percentage air voids, then we have air content, then we have gamma T, then we have G of S, G of solids, then we have specific gravity of solids. Now the most the engineering part of it is like interrelationship between all these variables actually. If I give you if a question asks you, okay, the water content of a soil is so and so, find the void ratio. So what is the, if I know water content, how can I find void ratio? If I know void ratio, how can I find porosity? Or some we have to find the relation between these soil actually, and there will definitely be a relation actually, because basic terms are solids, voids, and voids have two things, air or water. So if we know water, like suppose if we know the total volume of voids, and if we know volume of air, then we can definitely find the volume of water. So same way we have to find the relation among all these terms and make a formula of this thing, which we can directly and all these formulas actually are standard formulas. We can directly use them in the exam, but derivation should be we should be aware of derivation actually, because derivation actually will help us in other questions too. I will try to explain you derivation, and at the end of the day you have to learn the formulas. Like suppose I say total weight. What is total weight? Weight of solid plus weight of water plus weight of air, which can be neglected. Fine. Now using the water content concept, this concept, if I want to write weight of water is equal to water content into weight of solids, this is same plus water content into weight of solids, what will becomes is, taking weight of solids common, 1 plus water content. This is the total weight is equal to this thing. So this can be termed as my relation number 1. Now if I talk about void ratio, if I talk about total volume, what is total volume? Total volume is equal to volume occupied by solids and volume occupied by voids. Yes, voids definitely has volume of water plus volume of air obviously, but I can use the void ratio formula here. What is void ratio formula is here? Void ratio is volume of voids by volume of solids. So what is volume of voids? Volume of voids is void ratio into volume of solids. It becomes volume of solids by E into Vs, and this gives me Vs into 1 plus E, total volume. Fine, this is clear, this is easy also. Now we're going to start with porosity. What is porosity? Porosity is volume of voids by total volume. This is simple. Volume of voids, this is what the basic definition of porosity. Now if I talk about total volume is volume of solids plus volume of voids. And similarly, if I want to convert this volume of voids into volume of solids, it will become void ratio into volume of solids. Same concept here, volume of voids is equal to E into Vs. E into Vs. Now this thing also can be converted into, is equal to E into Vs. If I write it EVS by Vs by EVS, I cancel all the volume of solids, I get E by 1 plus E. So what my formula becomes, N is equal to E by 1 plus E. So I know the concept, I know how this formula is derived, but in case if in exam I am having the value of void ratio, then I can directly find porosity. It's a standard formula. If I'm having porosity, I can directly find void ratio. or we can interchange the formula also for simplicity. E is equal to n by 1 minus n. So if n is given, find E. If E is given, find n. Simple. You should know the derivation for sure, no doubt, but you should also be aware of the, you should also remember the Dirac formula, because in GATE you won't be having time to derive all the formulas. Now we're going to come to some other formula, like we have void ratio. What is void ratio? Void ratio is volume of voids by volume of solids. Easy. Now what I can do, I can multiply volume of water in the numerator and denominator. Volume of water, volume of water, volume of solids. This is because I want to introduce few more terms like degree of saturation. So if I want to include degree of saturation, I have to take volume of water into account somewhere or the other. Okay? So this is what inverse of S, what we have as degree of saturation to volume of water by volume of voids. So I can write is equal to 1 by S into volume of water by volume of solids. Now I can convert this volume of water into weight of water if I divide it by density. This volume of water can be converted to weight of water by density of water. I will get volume of water. Similarly, denominator also, weight of solids by density of solids. It will give me this thing. Actually, I want to I am looking forward to introduce a specific gravity in this formula, G. So if I want to introduce G, what is G? G is equal to gamma S by gamma W. So I will get G from here. And what is this? WW by WS. It is water content, W. So actually I am introducing two terms here, G and water content, and S is there. So ultimately what my formula will become, E is equal to, or say SE is equal to WG. This is the basic formula, WGS. This is of solids. SE is equal to WG. This can be directly used and it's very truthful formula. We will be using in many questions, actually many questions. So SE is equal to WG. Derivation is simple. We're going to come across one more formula. One more formula is like bulk density. We all know what's bulk density. Bulk density is basically total weight by volume. Total weight is WS by W of water by volume of solids by volume of voids. If I convert each and everything introducing gamma, suppose like WS plus W, I can write it like WS into 1 plus W using water content. This is water content. Actually this is W water content into weight of solids. So I'm writing it this way. Same way here also, Vs into 1 plus E. This we did earlier also, no issues. This we did earlier also, same way. So now what I'm doing is I'm again using these two terms, volume of weight of solids by volume of solids, and will introduce GS here. This thing can be noted. It will be used. See, if you have confusion, gamma S is technically weight of solids by volume of solids. This is simple. Weight of solids by volume of solids. On the other hand, we have G of solids is equal to gamma S by gamma W. We can write gamma S is equal to GS gamma W from here, and from here we can write this is equal to WS by VS. This is equal to WS by VS. So this becomes, we should use this thing many a place. Like what am I having it here also? Here I am having this thing, so I can use this thing directly. WS by VS is equal to GS gamma W. WS by VS is equal to GS gamma W. What it becomes is gamma T is equal to GS plus SE by 1 plus E into gamma W. Hope you got it. What I've just used here is I was taking I was having the numerator w I use it from this formula, S E is equal to WG, so I have taken W is equal to SE by G, and I have taken G common, so the G cancels out. Hope you got it, and we will get this thing very well in numerical part actually. Then we will start with few, like I'll just repeat this thing. Gamma total is equal to, we need to learn this formula, GS plus SE by 1 plus E into gamma W. This is bulk unit weight, this is bulk unit weight, GS plus now if I am finding gamma set is easy. What is gamma set? Gamma set is basically fully saturated. My soil is fully saturated. That means degree of saturation is equal to 1. What is degree of saturation? That is S is equal to 1. So if I am using S is equal to 1 here, what I get? GS plus E by 1 plus E by gamma W. It would be simple. Now if I talk about gamma D, dry density, from here, what is dry density? Degree of saturation becomes 0. Degree of saturation actually becomes 0 because we don't have any water in dry soil. So if I mark this S is equal to 0, I get dry density. Dry density is GS. Dry density is GS plus 0 by 1 plus E into gamma W. Fine. So this is my dry density. I found gamma saturated, I found gamma D and gamma T. Now coming to the gamma submerged part, we have gamma saturated. What is gamma submerged? Gamma submerged is equal to gamma sat minus gamma W, obviously. Now it is GS plus E 1 plus E